back with velocity 30 meter per second. The average force acting on the plate in Newton is. So first you have to calculate the change in momentum, then change in momentum per unit time is the force. See, the force that we want to calculate is equal to the change in momentum. So final momentum, final velocity is given 30 and initial velocity is given 50. So it will be 30 plus 50, not 30 minus 50. V minus u, because bullets are striking like this and then they are going back. So if initial velocity in this direction, the second time velocity changes. So minus of minus u, that is plus u. Okay, this term into mass of the bullet. Mass of the bullet is 0.03. Mass of the bullet into number of bullet fired per second, that is 200. Per second means you can consider this is divided by 1 second actually. So this one will give you the force. Because this is the scenario, this is the plate, the bullets are striking like this and then they are going back. So if they are moving in this direction, then you can consider the velocity to be, say, u I cap. When it is coming back, it is v j cap, v I cap. So change in velocity is final velocity minus initial velocity, but since initial velocity is in the negative x direction, so minus of minus will come and it will become positive. That change in velocity you have to calculate. A block rests on an inclined plane making an angle of 30 degree with horizontal. The coefficient of static friction between the block and the plane is 0.8. The frictional force on the block is 10 Newton. Then mass of the block in kg you have to find out. A block rests on an inclined plane making an angle of 30 degree with horizontal. The coefficient of static friction between the block and the plane is 0.8. The frictional force on the block is 10 Newton. Then mass of the block in kg, that you have to find out. See. Coefficient of static friction is mentioned. Frictional force on the block. See, this is mg, this is normal reaction. These are the components, that is mg sin 30, mg cos 30 and f. Okay. Frictional force is given. You have to find the mass of the block. So since the block is at rest, so we can write that mg sin 30. Sin 30 means half, equal to 10. G is 10. So m into 10 into half into equal to 10. So m equal to 2. Question number 8. A mass of 1 kg is suspended by a thread. It is lifted up with an acceleration of 4.9 meter per second square and then lowered with an acceleration of 4.9 meter per second square. The ratio of tension in the first case to the second case is, that you have to find out. When it is lifted up, then tension will be, suppose T1, then it will be mg plus ma. Okay, T will be mg plus ma. And when it is going down, then T equal to, then it is T1, then it is T2. T2 will be g minus ma. So from that you can find the ratio of T1 and T2. M will cancel, it will be g plus a by g minus a. So g is given 10 and 9.8 and it is 4.9. So 9.8 plus 4.9 divided by 9.8 minus 4.9, that is 3:1. A particle moves along the x-axis from x equal to 1 meter to x equal to 3 meter under the effect of force F equal to 3x square minus 2x plus 5 Newton. Work done in the process is. Simply you have to integrate. There is no other way because it's a square, x square term is present. So straightforward, do the integration f dx. Three x square minus 2x plus 5 into dx. X equal to 1 to 3. Complete the calculation. First term will be 3x square. Its integration will be 3 into x cube by 3. Then limit is 1 to 3. Then minus 2 into x, that is x square by 2. Limit is from 1 to 3 and then 5. It will be x, limit is 1 to 3. So this 2 cancel, 3 cancels. So it is 3 cube, that is 27 minus 1, 27 minus 1, 26. Minus 2 cube, the 3 cube, that is 3 square, that is 9, 9 minus 1, that is 8. And this one is 5 into 3 minus 1, 3 minus 1, 2, 2 into 5, 10. So 26 plus 10, 36, 36 minus 8, that is 28 joule. Okay. Next question. In stable equilibrium, a body has minimum potential energy. Force is 0 in both the equilibrium, stable or unstable. But in unstable equilibrium, potential energy is maximum. In stable equilibrium, potential energy is minimum. So option 2 is correct. Next question. Two bodies of mass 10 kg and 2 kg are moving with velocities 2 I cap minus 7 j cap plus 3 k cap meter per second and minus 10 I cap plus j cap minus 3 k cap meter per second. The velocity of their center of mass. The correct option is not in the A, B, C, D. The correct answer is not there in the options. Okay, so I will show you how to solve this problem. See, we know that center of mass of a particle in general R can be written as M1 R1 plus M2 R2 divided by M1 plus M2. Okay. Now if you differentiate this one with respect to time, then you will get the velocity of the center of mass. Then it will be M1 V1 plus M2 V2 by M1 plus M2. Simply put the values and calculate. V1 is given, V2 is given. m1 m2 given, calculate in the vector form, only in the vector form calculate, and you can see that the answer that will come, it's not matching. Okay. Next question 12. A flywheel of mass 50 kg and radius of gyration about its axis of rotation 0.5 meter is acted upon by a constant torque. Its angular velocity at t equal to 5 seconds is. First you have to calculate alpha. Okay, see, we know that tau equal to I alpha. Now torque is produced by constant torque. Constant torque is 12.5 Newton meter, that is 12.5. For the calculation of I, nothing is required because radius of gyration is given, and mk square, where k is the radius of gyration, is the moment of inertia. So I equal to mk square. So m is given 50 kg, k is given radius of gyration 0.5, mk square. So this is the moment of inertia into alpha. Now first calculate alpha. Okay, after calculating alpha, you have to use this equation omega equal to omega naught plus alpha t to find the value of omega. T equal to 5 seconds, omega naught is 0, alpha you can calculate and put it, so you can find the angular velocity at t equal to 5 seconds. Omega equal to omega naught plus alpha t. Okay. So calculate alpha from this. What is coming from this calculation? Omega equal to 5 radian per second. You have to calculate this omega after putting the value of alpha here. It will be 5 radian per second. Then question number 13. A body is released from the height equal to radius of the earth. The velocity of the body with which it will strike the surface of the earth. See, this is earth of radius r. The body is dropped from here, which is another r. Okay, so what will be the velocity of the body when it will reach here? See, at this point it is released, so its kinetic energy will be 0. It has only the potential energy, and potential energy at that point will be minus g m m divided by r plus r, that is 2r. When the body reaches near the earth's surface, then this potential energy will become minus g m m by r only plus some kinetic energy, that is half m v square. So you have to find that v. Don't use the formula v square equal to u square plus 2as. Okay, so this calculation will give you half mv square equal to gmm by 2r. So v equal to root over of gm by capital R. Now gm means gr square, because we know that small g equal to gm by r square. So g into capital M can be written as small g into r square. So if you put it here, you will get root over of gr. See, if you use the formula v square equal to u square plus 2as, then u is initially you will consider 0. Here it is v square, 2 into g into r, this distance, and you will get root over of 2gr. That is not the correct answer, because here the height above the earth surface is equal to the radius of the earth. So g is not constant. Acceleration due to gravity is not constant, and v square equal to u square plus 2as is applicable only for constant acceleration. Okay, since g at this huge height, g will vary, so using that equation you cannot get the correct answer. Then question number 14, that is also an easy question. The height at which the weight of an object becomes 1/16 of its weight on the surface of the earth is. That height you have to find. See, we know that g prime by g double prime, g equal to r square by r plus h whole square. Okay, this is the variation of acceleration due to gravity with altitude. Then if you multiply mass of the particle, then you will get this quantity is the weight at a height h, and this one is the weight on the earth surface, and it is said that it is 1/16. So 1/16 will be r square by r plus h whole square. So from that, taking square root, we can write 1/4 equal to r by r plus h. So we can write r plus h equal to 4r or h equal to 3r. Okay. And in this type of problem, always use this form of g prime by g equal to r square by r plus h whole square. Don't use that format 1 minus 2h by r, because that is an approximation when h is very less than r. And while solving this type of problem, you don't know from the beginning whether h is very less than r or not. So don't use the approximation formula, use direct formula. Okay. Next question, question number 15. A wire can be broken by a load of 20 kg weight. The force required to break wire of same material with twice diameter. That force is required. See, you know that Young's modulus y equal to F by A divided by delta L by L. So from this we can write F by A equal to y delta L by L, and F equal to y A delta L by L. Now F proportional to area of cross section. Then we can write that F proportional to radius square, because area of cross section means pi r square or diameter, whatever you thought. Twice the diameter. So if I consider radius square will also have the same ratio. So F proportional to r square or F proportional to d square, anything you can write and then calculate. Diameter is twice, so radius will be also twice. So force will become 4 times. So initially force is 20 kg weight, now 4 times force is required, that is 80 kg weight. Okay. twice the diameter means force will become 4 times, because it varies with square of the diameter or square of the radius. So 80 kg weight is the answer. Now question number 16. The work done in increasing the size of a rectangular soap film with dimension 8 cm into 3.75 cm to 10 cm into 6 cm is 2 into 10 to the power minus 4 joule. The surface tension of the film in Newton per meter. See, for this problem, we know that surface energy equal to surface tension equal to surface energy per unit area. Surface tension equal to surface energy stored per unit area. So here we have to calculate the increase in area. Then it will be surface tension force T equal to surface energy, suppose E, divided by increase in area. But remember, increase in area will not be the final area minus initial area. You have to multiply with 2 times, because soap film means inside there is a surface exposed to air, outside there is another surface exposed to air, so increased area will be 2 times. So you have to calculate that and substitute. This one is already given, E, that is the work done, that is the surface energy, that is 2 into 10 to the power minus 4 joule. Then this area, this one will be 10 into 6, that is 10 into 6 minus 8 into 3.75. 8 into 3.75. Okay, this entire term multiplied twice will give you the increased surface area into, this one will be in centimeter square, so you have to multiply with 10 to the power minus 4. To the power minus 4 to make it meter square. So surface tension will come in joule, Newton per meter. So don't forget to multiply this increase in area by this 2. Because increase in area is the on the 2 sides of the surface film, soap film. Inside there is air, outside there is air, and film is like this. If it is bubble, if it is droplet, then exposed area will be simply this subtraction. Air bubble inside water, single surface. Okay, then 2 raindrops, each 2 raindrops reach earth from clouds with different terminal velocities having ratio 9:4. Their ratio of their volume. We know that terminal velocity V equal to V proportional to R square. Okay. 2r square by 9 eta g into rho minus sigma. That is the entire formula. So V proportional to radius square. So ratio of the terminal velocity is given, that is given 9:4. So ratio of the radiuses will be 3:2. So ratio of the volume will be, make it cube. So it will be 27:8. From ratio of the terminal velocities, you will find the ratio of the radius and then ratio of the volume. Then question number 18. In a thermodynamic process, pressure of fixed mass of gas is changed in such a manner that the gas releases 20 joule of heat and 8 joule of work is done in this process. Done on the gas, 8 joule of work is done on the gas. If the initial internal energy of the gas was 40 joule, what is the final internal energy? Simply use the first law of thermodynamics and you will find the answer. It is 28 joule. dq equal to du plus dw. Now this dq, it is given 20 joule, that is minus 20. Heat is coming out of the system. du, final uf minus ui. ui is given 40 and 8 joule of work is done on the gas. Calculate UF. This is UI, initial kinetic energy, initial internal energy, that is given 40. UF minus UI, that is du. Okay, then choose the correct statement. Internal, first one is not correct. Internal energy is a state function. It is mentioned that it is a path function. Then heat is a path function while internal energy is not. That is correct. Option 2. Question number 20. An ideal engine whose efficiency is 40% receives heat at 500 Kelvin. If required efficiency is 50%, then intake temperature for the same exhaust temperature is. Simply use this equation, eta equal to 1 minus T2 by T1. So in the first case, eta is 40%, that is 40 by 100. This is equal to 1 minus T2 receives at, means 500. T2, this one is 500. Receives heat at 500 Kelvin means the hot reservoir's temperature is 500 Kelvin. So from this, first you have to calculate T2, and then in the second case, this is your equation 1. In the second case, efficiency required is 50%. So it will be 50 by 100 equal to 1 minus same exhaust temperature, means T2 remains same, and this T1 you have to calculate. So just solve from the first equation, calculate T2 and substitute in the second to find the T1. Previously T1 is 500, now new T1 you have to find out to increase the efficiency, because you know that if the hot reservoir's temperature is increased, then efficiency of the Carnot engine will increase. 600. No. 300. T2 is coming 300. Just substitute this value here and find T1. So T1 will be 600 Kelvin. Next, the root mean square speed of the molecules of a gas is 1260 meter per second, the average speed of the gas. See, V average, it is equal to root over of 8 kT by pi m, and V RMS equal to root over of 3 kT by m. Okay, so from that if you divide these two, this kT by m, this part will be cancelled, and then V RMS is given, you have to find out V average. But many approximation value etc. has to be taken. Because V RMS by V average, this one will be, RMS speed is given root over of 3 kT by m into pi m by 8 kT. kT cancels, m cancels, so it will be root over of 3 pi by 8. Many approximations are required during the calculation, 3 pi etc. Then question number 22. An object on a spring vibrates in a simple harmonic motion at a frequency of 4 Hz and an amplitude of 8 centimeter. If the mass of the object is 200 gram, then the spring constant. Because we can use simply this equation that omega square equal to k by m. Okay, we have to find out the spring constant. Frequency is given 4 Hz. Omega can be written as 2 pi into natural frequency, that is 4 pi square. Natural frequency, suppose f square. A heavy rope is suspended from rigid support. A wave pulse is set up at the lower end. Then the pulse travels with uniform speed. The pulse will travel with increasing speed. The pulse will travel with decreasing speed. The pulse cannot travel through the rope. What is the correct option? See, in a string, the wave velocity, velocity of the transverse wave in a string is root over of t by m. So as the pulse moving up, the length of the string increases. As a result, tension will also increase. Since the tension will increase, the velocity of the pulse will increase. So the pulse will travel with increasing speed. Because for a massless string, the tension remain constant, and for a string having mass, as you are moving from the hanging string bottom end to the upward, the tension will continuously increase, and maximum tension is at the junction where it is connected to the ceiling. And since the speed is v equal to root over of t by m for the transverse wave propagating through a string, then in this case the velocity will increase as the pulse is moving up. Next one, 24. Two waves of wavelength 50 centimeter and 51 centimeter produce 12 beats per second. The velocity of the sound is, see, we know that bit frequency equal to difference of the frequency. So bit frequency, that is given 12 bits per second, means bit frequency is 12 hertz. So 12 will be equal to n1 minus n2. Now, or n1 minus n2 or n2 minus n1 we can also write. I can write here n2 minus n1 suppose, or whatever be. Okay. Now this is equal to v by lambda 1 minus v by lambda 2, because frequency equal to v by lambda for the sound wave or any kind of wave, v by lambda 1 minus v by lambda 2. Now lambda 1 is given 50, lambda 2 is given 51. You have to calculate v. So calculate speed of sound. And remember that the answer will come from this calculation. If you directly put 51 and 50, it will come in centimeter per second. Then final answer is in meter per second. Into 51 into 12. It will come nearly 306 meter per second. Okay, next, a positive charge is moved from low potential A to high potential B. Then electric potential energy of the system increase. Why? Because it is going towards the higher potential, means you have to move the charge, positive charge, against the repulsive force. So you external agent must do work, and this work is stored in the system as its potential energy is gained. So potential energy of the system will increase. A parallel plate capacitor is charged and then charging battery is disconnected. If the plates are now pulled apart with insulated handles, what will happen? And how to find the answer? Don't say only option. Option 2 is correct, but how? See, once battery is disconnected and it is pulled with insulated handles, means the net charge on the plates remain constant. Okay, so you can write that potential energy U in this form, Q square by 2C, where Q is constant. Don't write half CV square, because when you pulled it apart, C will change, V will also change. Because distance increases, so field remains same, distance increases, then potential difference changes. So both the quantities are variable in half CV square format, and you may have difficulty in calculation. But since it is said that battery disconnected, pulled with insulated handles, means charge remain constant, so you come to this formula, Q square by 2C. Then Q square by 2C, C is epsilon naught A by D, this D will be upward, so U proportional to D. Now as D increases, potential energy will also change. Q square by 2C epsilon naught A by D, U proportional to D. Which one is the correct option? Potential difference increases. This shows that potential energy will, D increases means potential energy will increase, but option 2 is not correct, because potential energy decreases is given. So potential difference will increase. 3 is correct. Three is correct. See, first option cannot be correct because C equal to epsilon naught A by D. D increases means C will decrease. So first option is not correct. Second option, potential energy decreases. This shows that U proportional to D. So as D increases, potential energy will also increase. Third option is potential difference. Potential energy stored, this one. So this one shows that U varies as D, but potential difference V, that is simply E into D. E remain constant because parallel plate capacitors are considered to be infinitely extended, and field between them is sigma by epsilon naught. So that remain constant. So D increases means potential difference will increase. And last one is charge and potential difference both remain same. That is not constant. Charge remains same but potential difference changes. In this context, I will discuss one more question. One is this part. If it comes to the potential energy stored, electrostatic potential energy stored, if you pull the plate with insulated handles after disconnecting the battery, charge constant, so U proportional to D. So as you move this one, then potential energy will increase. Okay, potential energy stored, electrostatic form, that will increase. There is another question comes. Without disconnecting the battery, if you pull the plates away, then what will happen? Without disconnecting the battery, if you pull the plates away, then what will happen to the electrostatic potential energy, U? You cannot use this form, because battery is still connected means it is maintained at constant potential difference. So you have to use this formula, U equal to half CV square. Now V is constant. Now C means half epsilon naught A by D into V square. Now suddenly the formula changes, U proportional to 1 by D. So as D increases, potential energy will drop. Electrostatic potential energy stored will be dropped. So two different situations you have to remember. That if it is, we are talking, in the question it is said that potential energy, how it will change. If the batteries are disconnected and it is moving apart, then charge constant, and immediately you will find U proportional to D. So D increases means U increases. If battery is connected and we are moving away, then charge is not constant, then potential difference is constant, then U is inversely proportional to D. Okay, you can take a small break. That is 2:5. So it is a balanced twist-on bridge. So no current will flow through the 12 ohm resistor. Then what is the current flowing through the 4 ohm resistor, that you have to calculate. So in the upper branch, how many current, what will be the current going? That is 1.4 into inverse ratio of the resistance. Ratio of the resistance is, that is 5 by 5 plus 2 in the upper branch. That is through the 20 ohm. Okay. 5 by 5 plus 2 because they are in parallel combination, because equivalent circuit is like this. After removal of the bridge resistance. Okay, so current entering here is divided into two parts. So current flowing through this part we want to calculate, that will be in the inverse ratio of the resistance. That will be 20:50 means 2:5. So inverse ratio of the resistance is this one. So it will be 1.4 into 5 divided by 7. That is 0.2 into 5, that is 1 ampere. Okay. Because whatever be the current going through this resistor is the same current is going through this resistor. So ratio is 2:5. So through the larger resistor, small current will go, because in the parallel combination I1 R1 equal to I2 R2. So through the smaller resistor, larger current will go. So it will be 5 by 5 plus 2, the ratio. Question number 28. If you can't find this, it is difficult for you, then you have to solve by long method. By taking I1, I2 and all these things, you have to solve them. See what I am doing. This current is going here, I1, suppose this current is going here, I2. This resistance suppose R1, this resistance suppose R2. Then total current is coming I, suppose. Okay, then I equal to I1 plus I2 and I1 R1 equal to I2 R2. From that I have to find out I1. Okay, so from this second equation I can write I2 equal to I1 R1 by R2 and substitute this here. What you will get? You will get I equal to I1 plus I1 R1 by R2. So I equal to I1 common, 1 plus R1 by R2. So LCM will be R2 plus R1 by R1. So I1 will be equal to I into R1 divided by R1 plus, sorry, this one is R2, I2 is I1 R1 by R2. So this is R2, this is R2, this is R1 plus R2. Okay, I use this formula directly. This I 1.4 R2. What is R2? R2 is given in the problem, it is given 20. R2 is given 20 and R1 is given 50. So 50, R2 is given 50. See, I is there, R2 is given 50, R1 is 20, this one is 50. So I use that ratio directly. 50 by 20 plus 50, that is 50 by 70, 5 by 7. I use that. So whenever this type of problem comes in parallel combination, you can always write that I1 will be equal to I into R2 divided by R1 plus R2, and similarly if you ask to calculate I2, then it will be I R1 by R1 plus R2. If you remember these two formulas, you can solve the problem easily without solving all these things. Means total current into current through which resistance is required? R1. So I will write here the other resistance divided by sum of the resistance. Because otherwise in the exam there is not that much time to derive all these formulas and then solve. Whenever in the parallel combination current splits, you can use these two formulas directly to find the current through two resistors in which are in parallel. Okay. Then next problem, two identical cells connected in series send 10 ampere current through a 5 ohm resistor. When they are connected in parallel, they send 8 ampere current through the same resistor. Resistance, what is the internal resistance of the cell? See, first two cells are connected in series. So each cell having EMF E, internal resistance R, smaller E R. They are connected with an external resistor, capital R. So they send a current through this. So in the first case, I can write I equal to 2E divided by R plus 2 smaller. Because two internal resistance are connected in series, and internal resistance and external resistance are also connected in series. So total resistance will be R plus 2R, total EMF will be 2E. So this is I in the first case. In the second case, these two cells are connected in parallel. R, E, R, and connected with the same external resistance R. Now the current is, say, I prime. Now what is I prime? In the parallel combination, EMF remains same. Internal resistance will be R plus smaller by 2, because these two are connected in parallel. Their equivalent will be R by 2, and that smaller by 2 is connected in series with this external. Now put the values and find smaller. E will be there. If you divide, E will cancel. You can find smaller. I is given in the first case, I is 10 ampere and external resistance capital R is given 2 ohm, 5 ohm. In the second case, capital R, I prime will be 8 ampere. Then you will find two equations, divide these two to eliminate E, and you will find the value of small r. Okay. This one is, that is 2E divided by 5 plus 2 small r. Second one here, 8 ampere current flows equal to E by 5 plus R by 2. So I can cancel, one will be 5. Okay. Then we can write here E equal to 25 plus 10R. From this equation I can write E equal to 25 plus 10R, and from this equation I can also write E equal to 40 plus 8R by 2, means 4R. So both E I will equate. Okay. Then you can find that 6R equal to 40 minus 25, that is 15. Then R will be 2.5. Okay. Nine. 3 long ones. This one complete. Three long wires are given carrying current in the same direction. So I will write it like this: I1, I2, I3, or better to write I1. See. I, this is taken as 2I, this is taken as 3I, 10, 20, 30. So I consider I equal to 10. Okay. Then this distance are given 2D, this is also 2D. This is one point, this is another point. At this 2 point Q and P it is mentioned. This one is Q, this one is P. So you have to find the ratio of the magnetic field at point P and Q. Fine. See. All the currents are in the same direction. Then at point P first. For this is coming out. For this it is going in. For this it is going in. So I can write that at this point P, the magnetic field is BP. That will be equal to mu naught 3I by 2 pi d, because this distance is d, 3 pi by 2 pi d for this square. Then for this square it will be mu naught 2I by 2 pi d, because this distance is also d. Then for the last square it is minus mu naught I divided by 2 pi Now this distance is 2d plus d, that is 3d. Okay, 2d plus d, that is 3d. Because from this point is at a distance d, from this is at a distance d, from this point is at a distance 2d plus d, that is 3d. So you can calculate BP from here. Similarly, you have to calculate BQ. Now check for BQ. This field is inward, this field is outward, this field is outward. So I will consider that BQ equal to mu naught I by 2 pi d for the first, for the second wire, and it is going inward. So inward is taken as negative. Since it is inward, I will put a negative sign. Here, this one 3i, it is coming out. It is going in, it is going in. To going in field will be taken with a negative sign, and coming out is taken with positive sign. So here first field is going inside, so it is in with negative sign. Then for 2i, it is coming out, so it is positive. So it is mu naught 2i divided by 2 pi d. Last one, it is also coming out, mu naught 3i by 2 pi into 3d. And then calculate and take the ratio. So this one, if you take mu naught I by 2 pi d common, then it will be 3 minus 2, and this one will be minus 1 by 3. 3 minus 2 minus 1 by 3, that is 1 minus 1 by 3, that is 2 by 3. So this one will become 2 by 3 into mu naught I by 2 pi d. Okay, 2 by 3 into mu naught I by 2 pi d. This one, mu naught I by d is taken common, by 2 pi d is taken common. So this one will be minus 1. This one mu naught I by 2 pi d common, so it is 2 mu naught I by 2 pi d common, that is 3 by 3, that is again 1. Okay, so 1 cancel, so it will be 2 times mu naught I by 2 pi d. Now take the ratio. BP is to BQ, then it is 2 by 3 is to 2. রেশিও কি উল্টো দেওয়া আছে? কোনটা বলো তো? ও আচ্ছা আচ্ছা, উল্টো দিক থেকে ধরা হয়েছে, ঠিক আছে। আমি ওই দিকটাকে, হ্যাঁ, that side is taken as 10 and in the problem this side is taken as 10. So let us change this. QBP, same thing. Okay, then question number 30. A 0.8 meter long solenoid has 800 turns and has a field intensity 2.52 into 10 to the power minus 3 Tesla at its center. What is the current in the wire? This is very simple. Just use this formula for the solenoid. B equal to mu naught Ni. You have to find that I only. B is given, turns per is given, length is given. So turns per unit length you can calculate and find I. B given, mu naught given, mu naught you know, 4 pi into 10 to the power minus 7, N given. You have to find out I. Okay, so it is coming nearly 2 ampere. Small n is turns per unit length, that is 800 by 0.8. Magnetic field is given, you have to find out I. Okay, next 31. A charged particle having charge 2 coulomb is thrown with velocity 2 I cap plus 3 j cap inside a region having E equal to 2 j cap Newton per coulomb and magnetic field 5 k cap Tesla. The Lorentz force acting on the particle. See, it will feel an electrical force, that is QE, along with a magnetic force Q into V cross B. So this one will give you the Lorentz force. So just this, calculate this. So first calculate V cross B, then add E and multiply with Q. This is the total Lorentz force felt by the particle. See, when you calculate V cross B, V is given 2 I cap plus 3 j cap. and B is given 5k cap. Okay, so 5 into 2 10, I cross k will be minus j, and another term will come j cross k will be plus I. Okay, so it will be 15I minus 10j. So Q is already given 2 coulomb, E is 2j plus this one is 15I minus 10j. So it will be 15 into 2, that is 30 I cap, and this 2 8 16 j cap. So option 1 is the correct. 30 I cap minus 16 j cap. Second one also easy, you have to subtract 1. Mu r equal to 1 plus chi. So mu r is given, you have to find chi. Okay, then question number 33. The resistance of a silicon junction diode whose VI characteristics is as shown in the figure. See, when it is shown that in the graph 3.7 volt, then to find the voltage, rise in voltage, you have to calculate 3.7 volt minus this barrier potential. Okay, so dynamic resistance R will be 3.7 minus barrier potential. Barrier potential is given 0.7 divided by current is 30 milliampere, means 30 into 10 to the power minus 3. Calculate. So it will be 3 by 30 into 10 to the power 3. So it is 0.1 kilo ohm. The horizontal component of earth magnetic field at a place 4 into 10 to the power minus 4 Tesla and deep is 45 degree. A metal rod of length 20 centimeter is placed in north-south direction and is moved at constant speed of 5 centimeter per second towards east. What is the induced EMF in the rod? Don't think this is a question of earth magnetism. It is a question of electromagnetic induction, motional EMF. So in this case it will happen, the rod is placed in north-south. Magnetic field is also directed here, north-south direction, and it is moving in this way. Magnetic field lines like this, B, and velocity of the rod in this direction towards east. Okay, so deep angle is not required in the problem. Deep angle is not required in the problem because this angle is required, and that is 90 degree between V and B, and motional EMF is EVB, E equal to VB L sin 90. Sin 90 is 1, so no required, just multiply. So V is given 5 meter per second, centimeter per second, so 5 by 100. B is given 4 into 10 to the power minus 4 Tesla, and length of the rod given 20 centimeter, that is again 20 by 100. And now calculate. Because horizontal component is already given. Okay, so deep angle is not required. If it is said that total magnetic field of earth at that point is given and deep given, then you have to calculate B cos theta cos 45 to calculate the horizontal component and then proceed to the problem. It is already mentioned what is the horizontal component, so deep is not required. And remember, deep angle is not the angle between V and B. V and B angle is 90. So deep angle is here only to confuse. Okay, then according to Lenz's law of electromagnetic induction, the induced EMF in the direction opposing the change in magnetic flux. First one is correct. Question number 36. A coil has a resistance 30 ohm and inductive reactance 20 ohm at 50 Hz frequency. If an AC source of 200 volt and 1000 Hz is connected across the coil, the current in the coil will be. First you have to calculate impedance of the circuit. Impedance is Z equal to root over of R square plus XL square. So R is given 30, XL is given 20 ohm, inductive reactance 20. Inductive reactance is already given. It is in ohm already, so just calculate impedance of the circuit, and then 200 by this impedance will give you current. So no need to introduce frequency in the calculation because already XL is given in ohm. Then after that, for finding the current, 200 by Z. it is coming z equal to root over of 1300, that means 10 root 13 root 13. Root 13, so z will be 200 by 10 root 13 . This is peak value is coming. Huh? Frequency is inductive reactance will change. Okay, 100 is given na. 20 ohm at, oh, we have to calculate, okay, right. So first we have to find L, XL equal to omega L. So XL is given 20 equal to omega is 50, then L is, we have to find out. So L equal to 2 by 5 Henry, right. Then finally XL prime, suppose, that we have to calculate, that is omega L. Omega is now 100 into 2 by 5. That is 40 ohm. So this one will be 40 . Square, so this one will be 50 ohm. Then I naught equal to 200 by 50, that is 4 ampere, correct. Frequency is different, 100 Hertz. Question number 37. A plane electromagnetic wave EZ, E equal to 100 cos 6 into 10 to the power 8 T plus 4x volt per meter, where x is in meter and T is in second, propagates in a medium. What is the refractive index of that medium? First calculate the speed of this wave. First calculate the speed of this wave, then use mu equal to c by v to find the refractive index. See, E is given. So E I can write in this format, E naught cos omega t plus minus, that depends on the whether it is going in the positive x direction or negative x direction. So speed of the wave that we can calculate, it is equal to speed of the wave v equal to omega by k. Okay. So coefficient of t is omega, that is given 6 into 10 to the power 8, and coefficient of x is k, so that is 4. So it is coming 1.5 into 10 to the power 8 meter per second. This is the speed of this wave. Now we know that mu equal to c by v, so it is 3 into 10 to the power 8 by 1.5 into 10 to the power 8, this is 2. So refractive index of the medium is 2. if two coherent waves are represented by y1 equal to 4 sin omega t and y2 equal to 3 sin omega t plus pi by 3, the interfere at a point, the amplitude of the resulting wave will be about. What will be the amplitude of the resulting wave? See, you can use simply this form: a square equal to a1 square plus a2 square plus 2a1 a2 cos delta. Where delta is the phase difference, that is given pi by 3. a1 a2 given, a1 is 4, a2 is 3. So a1 square means 16, 9, 2 into 4 into 3, 24 cos pi by 3 means cos 60. Cos 60 is sin 30, that is half. So it is coming 16 plus 9, 25, 25 plus 12. 37, 6 point something, only one option is there, 6.1. A square 37, so A is 6.1. The fringe width in Young's double slit experiment increases when beta equal to lambda capital D by small d. So just check the correct option. Distance between the slit and the slit plane and the screen increases, means capital D increases, then beta is directly proportional to capital D. So option 4 is correct. A defective eye cannot see close object clearly because their image is formed beyond retina. Rainbow is formed due to option 3, internal reflection and dispersion both. Next one, when light of maximum wavelength 300 nanometer falls on a photoelectric emitter, photoelectrons are liberated. For another emitter, however, light of wavelength maximum wavelength 600 nanometer causes photoelectric emission. The ratio of the work function, you know that work function W equal to Hc by lambda naught. So for two material, so we can write W1 by W2 equal to lambda naught 2 by lambda naught 1. For two materials 1 and 2, they are inversely proportional. So lambda naught 1 is the threshold frequency wavelength for the first material and lambda naught 2 is the threshold frequency for the second metal. So the ratio will be 2:1. because 6000 is to 3000 is 300. 600 is to 300. The Boolean equation for the circuit as shown. First, there is a NOT gate in the line A, so it will be converted to A complement. B will be same, then they are passing through an AND gate, means A complement into B. Option 3 is correct. Okay. After one alpha particle emission and beta particle and one beta particle emission from a nucleus. Option 4 correct, because alpha emission atomic number decreases by 2 and beta emission atomic number increases by 1. Then ultimately the decrease in atomic number is by 1 unit. So atomic number reduces by 1. To measure the intensity of light, we use option 4, photodiode with reverse bias. Where you see this? To measure the light intensity? During the cricket match, overcast condition, sometimes light is decreasing. Umpires will check whether the light intensity is proper or not. Previously, match stopped, but nowadays they use floodlight. Previously, when there was a test match, and whenever India is in very poor condition, about to lose that match last day, sometimes umpire comes and check the light meter. All Indians, all of us will thought light is very low, it will be very low, and immediately the match will stop and India is saved somehow. Two trains 101 meter and 99 meter in length are running in opposite directions with velocities 54 km per hour and 36 km per hour. In what time will they completely cross each other? When they will completely cross each other, they will cover a total distance equal to the sum of the length, that is 200 meter. 101 plus 99, that is 200 meter is the total length that they should cross to completely cross each other, because the situation is like this. This is the complete crossing, means entire distance of both the length trains will be crossed. Then since they are moving in the opposite direction, their relative velocity will be 54 plus 30, that is 90 km per hour. This has to be converted into meter per second. 90 km per hour into 5 by 18, so it is 25 meter per second. So 200 by 25, that is 8 seconds. 8 second time is required. Total distance covered 200 meter to completely cross each other. Relative velocity 90 km per hour. 90 km per hour means 25 meter per second. Then total distance by this relative velocity will give you the time taken. Okay. Then a body of mass m is rotating in a vertical circle of radius r with critical speed. The difference in kinetic energy at the top and at the bottom. If it is rotating in a vertical circle, suppose at the top it is half m, say v 2 square. I consider the v2 is the velocity at the top, half m v1 square. v1 is the velocity at the bottom. Then it will be half m, this is root 5 gr. So this will be 5 gr minus this one will be root gr. Because at the critical speed, if it is rotating, so it can just complete the circle, and for that the minimum speed at the top will be root gr, and for that to achieve minimum speed at the bottom will be root 5 gr. Then calculate. It will be 2 mgr. So difference of the kinetic energy will be 2 mgr. The angular frequency of simple pendulum is omega radian per second. Now the length is made 1/4 of the original length, the angular frequency becomes, see, we know that T equal to 2 pi root L by G for the simple pendulum. Okay. T equal to 2 pi by omega. Two pi cancel. So we can see that omega equal to root over of G by L. Omega equal to root over of G by L. So these are inversely proportional. So I can write omega 1 by omega 2, that is equal to root over of L2 by L1, and now calculate. So initially length I consider L, then final length will be 4L, and this is omega initially, now it is omega 2, then this one will be omega 2 will be omega by 2. So option 1 is correct. Length is made 4 times. So previously if length is L1, now length is 4L1. Which one? L by L1 is L. Now it is made 1/4 or 4 times? Oh, 1/4, sorry. So omega previously, now it is omega 2, it is root over of 1/4. Okay, so L1 by 4. So omega 2 will be 2 omega. Oh, 1/4, I consider 4 times. Then 49. The radii of circular orbits of two satellites A and B of Earth are 4r and r respectively. If speed of the satellite A is 2v and speed of the satellite B, what? That you have to find out. Okay? Now, we know that V equal to root over of Gm orbital speed, root over of gm by r. Don't use root gr because g is not constant. So use this one, v equal to root over of gm by r. Then you can write that v proportional to 1 by root over of radius. Then VA is VA by VB equal to root over of RB by RA. Okay? Then calculate. Speed of the satellite A is given. Satellite A speed is 2v. This is VB. Second satellite's radius is r. First satellite radius is 4r. Then calculate VB. R cancel. So VB equal to 2 into 2, that is 4V. Okay. If the distance between successive compression and rarefaction in sound wave is 2 meter and the velocity of the sound is 360 meter per second, then the frequency is. See, frequency n equal to v by lambda. N equal to v by lambda. V is given 360. Lambda is given 4. So it will be 90 Hertz. How it is 4? Because it is given that successive compression and rarefaction. Compression and rarefaction means half the wavelength is given. 2 successive compression or 2 successive rarefaction is entire wavelength given. So half the wavelength equal to given 2 meter. So entire wavelength will be 4 meter. Distance between 2 successive compression or successive rarefaction is wavelength. Here it is given successive compression and rarefaction, means half the wavelength.